Please give a very warm welcome to Dr. Irwin Adam.
Thank you, Mr. Jeff. Good afternoon. That was a very involved introduction. Most of those things are true. So good afternoon, everybody, and I hope you all enjoyed your lunch. We're going to start off by thinking about what we do at the dinner table. You know, food is something that's extraordinarily personal to each and every one of us, right? When we feed one another, we're taking care of one another, right? We're sharing our stories with one another. We're sharing our history, our culture, our traditions. It's something that we can all really rally around. This is also one of the most intimate things that we do, right? When we share food with our family, with our friends, with people we care about. When we feed them, we're creating their hair, their nails, the energy that drives them through their day, and we're making them into the person that they are. So I want us to really think about the dinner table today and start to recognize the fact that it's no longer only a place where we dine, but it's also becoming a place where we negotiate. Welcome to the Anthropocene. This is the beginning of an epoch that is marked by the human transformation of the world at large. This is a new geological era that is marked by everything that we've done in order to transform the earth for better or for worse, right? So if you think about how we make decisions on a daily basis, all those decisions end up as artifacts that will, in the future, mark this as the Anthropocene. If you can imagine a geologist 2 million years from now going through sediments from this era, they'd say, oh, look, there's some plastic, there's some particulate nuclear material over there, and that's how we would be characterized and judged. And so those decisions that are being negotiated at the dinner table today are contributing greatly to the transformations that are happening in the world at large. So we're faced with a very clear challenge over the next 20, 30 years. We have 3 billion new global citizens joining us on this planet, and we need to feed them. That's a lot of food that needs to be produced and distributed, and it has to be done in a way that's sustainable and also provides for healthy, nutritious food for those people. And in fact, we've actually seen this problem before. Taking us back to the 1950s, where we had a major population boom that was very much centered around Southeast Asia, and that region was no longer able to sustain the population growth using the food that was produced there. And so we entered the Green Revolution, which in 1970 we awarded the father of, Norman Borlaug, with the Nobel Prize for actually saving the lives of 1 billion people by really applying technology in the transformation of agriculture. And really saying, we need to feed 1 billion new people very quickly. How are we going to do it? And most critics at the time believed that we weren't going to be able to feed everybody, that people were going to starve, people were going to perish. But in fact, when we rallied scientists together from around the globe, we were able to completely transform the way we grow things. And so that really was the foundational premise of what went down in the Green Revolution. And so the product that came out of it was really this idea of the creation of new high-yield varieties of grains and rice, right? So at the time, we had namely subsistence farmers around the world growing food. Yields were varied. And what Norman Borlaug and his contemporaries were thinking was, hey, we need to intensify production. We need to actually grow more per acre, and we need to be more successful at growing food in all of those acres. And so what they did is they developed these new varieties of wheat. And so these actually started off in Mexico. And what was unique about their characteristics was, one, they had shorter stalks, as you can see in the image. We call those dwarf varieties. And the reason why that's important is, something that maybe not all of us think about, but when you're growing wheat in the field, it's subject to weather, wind, rain, hail. And so when you have tall stalks, those wheat shafts collapse. And so by having shorter stalks, we were able to protect our fields, and we were able to be more successful in growing those grains. Further, we had larger heads on those stalks, meaning there was more grain per stalk that could actually be used for food. So this is incredible, right? We've completely transformed the plant that we're growing for food in a way that allows us to grow more food per acre and feed more people. Unfortunately, the story doesn't end there. If we take what we've learned from the Green Revolution and we fast forward to today, we find that, okay, well, we figured out how to make a lot of food and how to feed 1 billion people, yet today we still have 1 billion people who go hungry every day. Right? There's 800 million people on Earth today who suffer from malnutrition and hunger in a world where we produce too much food. Right? We have between 7 and 8 billion humans on Earth, yet we produce enough food for 11 billion. So how is this possible? What went wrong? We need to recognize that if we're going to feed the next 3 billion people, we need to change the way that we produce food, right? We're going to have to rethink and reimagine how food is brought to market. And in doing so, we have to both consider nutrition and we have to consider sustainability in order to meet our climate change goals. Because the realities are, if we come to 2050 and the Earth is inhospitable to us, well, then it doesn't really matter that we can feed ourselves. So a few of the issues that are happening, why we have so much food produced and so little to show for it, is number one is global food waste. This is a major problem, occurs all over the world. About 1/3 of all food produced on Earth goes to waste. Recently, there was a study that came out in Canada just this last month that showed over 50% of food produced in Canada goes to waste. And that both comes from the consumer, but predominantly is on the supply side of the system. Right? So we're making enough food to feed everybody, yet people are going hungry and we're wasting it. Another reason this is happening is land is changing and yields are changing in our fields. So NASA does a really great imagery of how climate change is affecting different parts of the Earth. This is in Europe between 2015 and 2017. On the bottom, you can see kind of the green lands, and at the top, you can see as drought has hit these regions, how crop shortages are happening because we can no longer grow. So it's very clear to us that there is this challenge, right? But the question for us today is how can technology provide a solution? And what I find incredible about the world of food is we often think about it as this very conventional, old school space with farmers and people who are, growing food. And it's not something that happens in a city, so we don't really care about it too much. But food has really become a nexus for all forms of technology. Really, we're seeing the meeting of automation, artificial intelligence, synthetic biology, and every contributor coming into this space in order to really shift us very rapidly to a new way of producing food. So if we're going to connect food to kind of climate change, I think it's helpful to understand where the issues with traditional agriculture come from when it comes to greenhouse gas emissions, right? So you can see there's kind of all these, there's all these different sources of gases that come out, but predominantly the two main gases are methane and nitric oxide, And so where those two are coming from are mostly from ruminants, so from things like cows and other animals, and we've probably heard this before, but that they're burping and they're farting and they're giving us methane. And then a lot of the nitric oxide comes into the atmosphere from the application of fertilizers to the ground that then are released to the atmosphere. And so this is a really gnarly looking chart here, but I think it's helpful then to also understand within the context of all greenhouse gas emissions in the world where agriculture fits in. So, we have energy as the number one source of greenhouse gases. Number two is really agriculture over here. So transportation and agriculture tend to be neck and neck, right? So agriculture, it's not just like this little component of what's happening, it's really a large contributor. And so we do need to reimagine both how agriculture is contributing to greenhouse gas, but also how to augment it for the future. And then diving in a little bit deeper into that agriculture component, the bulk of those emissions are coming from livestock, right? So very clearly, we can see here there's a showing of different CO2 equivalent emissions across different species of animals that we raise for livestock, beef cattle being the highest, and then as we go smaller and smaller to birds, we have fewer emissions. So it's important for us to just contextualize what's going on here, right? So we are growing food that is transforming the climate and the environment, which is making it more difficult to grow food, which then becomes a challenge to feed more people. So we're kind of caught in this loop. As a result of some of the recommendations from the IPCC on that we have 12 years now to meet our climate change goals, there is a lot of research and a lot of study going on now how to transition our food system into a future food system that is responding and going to acknowledge and in fact be ready for the tomorrow of eating. So there's this great article that actually goes through and examines, and this just came out in December, but it goes through and examines our food system and plays with different futures. And it says, hey, if we were to stop eating beef, how would that contribute? Or if we were to bring some technology into the picture, whatever the technology may be, say automation, how does that transition? And so they go through this exercise, and it's very helpful to kind of see where this lands us. And I know this is a little bit challenging to digest, but we go through these different categories of greenhouse gas emissions, cropland use, blue water use, nitrogen and phosphorus application, which are some of the intensive chemicals we need to grow the food. And you can see comparisons between where we are, say, today in 2010, or back in 2010 versus 2050. Right? And a large part of that is actually animal products, all these red bars, but you can see there's significant increases of environmental pressure that are occurring if we continue on the status quo. And I promise this is the last horrible graph that I'm going to show, but I think it really does hit home kind of an interesting notion of, well, there's all these different strategies we can use in order to transition our systems, but not just one of them is going to solve the problem. So similar to before, we have greenhouse gas emissions, cropland use, et cetera, but now in all the different colors, which is where they got a little crazy here, but they propose different futures. So one is cutting waste by half, right? So if you look at this yellow bar here, the darker yellow, the more orange versus the yellow, that's waste by half versus waste by a quarter. Right? So if we bring our waste down to 25% of what it is today, that's the reduction that we're going to see. And then they go through other variations of how we can transition and transform our behaviors. And so that includes bringing in technologies. You can see there's reductions in the gray bars. And then you can see dietary changes and shifts towards more flexitarian diets. And I'm really trying to set the stage here for you. Basically, reiterating what Jeff just shared with us, there isn't going to be one single solution that's going to solve this problem, right? This is a systems level problem that has a lot of different contributors who are compounding it. And so we have to look at multiple angles for attack. And so that brings us to the farm. And so this is where things are going to get a little bit more fun, less graphs. But I really want us to start putting ourselves in the shoes of a farmer. And start to really understand what farming looks like today. How many of you have been on a farm in the last 5 years? Okay, amazing. How many of you have ridden in a tractor in the last 5 years? How many of you have used GPS technology that automatically drives that tractor in the last 5 years? I haven't used it. But you've seen it. So very standard for a farmer today is to have an interface, just like an iPad or a digital interface, that guides them through their own field. And so, we still have all of these old tractor systems that we're very familiar with, but farmers are using GPS technology and automated driving technologies in order to actually map their ways around their own fields and to set their courses for everything from sowing to tilling to application of seed and fertilizer. And what's important here is that this is a tool that's giving farmers a lot more efficiency in the way that they are functioning, right? This is something that's very simple to install within their system, but suddenly makes it so that they don't make mistakes. And I can't say enough how the human component of farming actually is very challenging, right? Like you're driving this giant tractor, you could have like 20 meters behind you, and you're going, and you're trying to, ride along in a perfectly straight line. In order to line that up every time you go up and down, and then say you have to go to the bathroom in the middle of it, so you get out and stuff, you stop, and then you have to line it up again. This is something that is very challenging to do and actually leads to people missing spots on their farm or over-applying fertilizer to a section of their farm. And so older styles of farming had a lot of inefficiencies in them, and specifically, over-application of herbicides, pesticides, and fertilizers. The new farmer starts using precision farming technologies, right? So Canada has actually been a very strong player in this, where we developed CanSat-2, which relays satellite imagery to the Earth, giving the agriculture industry very, very clear views about what's going on in their fields. And we can get information about moisture content, temperature, even to the extent of plant growth on the ground. And so using this type of information, suddenly a farmer can say, hey, I don't need to apply fertilizer across all my field, or I don't need to water all my field. I need to localize these applications, right? So suddenly we're bringing down the use of phosphorus and nitrogen and all these other things that we're trying to remove from the agricultural contributions to climate change. And I really love this video because it shows you how farming in some ways is becoming a computer game. So, this is a map of a farm, and all of these icons are indicating different crops that are being grown on the farm. And you can see that several of them are red in color, which means that those parts of the field need attention, right? And so the attention they might need is some water, some fertilizer, whatever it might be. In this specific program, the producer, the farmer, can actually go into the land itself and can actually select a contractor to go and apply whatever is needed in that part of the field. Right? So these are systems that are starting to close the loops. And so we're having pinpoint precision within agriculture, which is allowing us to be more efficient. And you can watch as applications are happening to the field. You can see how applications should actually be varied across a field as well, so that you're much more specific in the way that you're treating your crops and the way that you're treating the soil. Right? Again, I can't hit home enough how incredibly useful and important this is. This means that we are limiting the use of limited resources, right? We are saying that this is how we utilize our water, this is how we utilize these chemicals in a specific way that results in higher yield, better growth, and better environmental conditions. And so here you have the integration of weather patterns, right? So here you can see rain is coming in across, so the farmer can zoom into his fields again, and he can see which fields, which plots of land need water. And so he can make that decision that, hey, well, guess what? We're not going to water those today because there's rain coming in, right? So farming is becoming more and more automated, and the realities are we need automation in farming. Here you can start seeing some of the robotics that are coming in. And why I'm sharing this with you is for you to understand that farming is a very manual process, right? So there's two versions actually today, right? We have conventional farming, which has gone into large tractors, and we have huge plots of land, and we're kind of bulldozing everything, and it's just going. But there is a significant shift towards more sustainable agriculture processes, such as organic farming, regenerative farming practices that are actually better for the soil. And often the argument against those practices is that, well, they're too expensive, right? So, and all of us can agree that you go into a grocery store when you see something that's organic versus not organic, that the organic, apple or whatever it might be is going to cost more than the not organic apple. Well, suddenly we have the ability to deploy technologies into the fields that bring all those costs down. One, because reduction of labor costs. And in fact, it's actually very difficult to find agricultural labor in general. Number two, we can start pinpointing how we apply our resources, whether that's water, whether those are chemicals, or whatever they might be. And so these are some of the more prototypey robotics that are being created. So you have that apple picker there. You have smaller systems that are being deployed. And these are becoming systems that are accessible to a regular farmer. Right? So this isn't technology that necessarily is economically completely prohibitive. Farmers today, in fact, are spending $500,000, $800,000 on a tractor. So like it's, this isn't a huge economic hindrance, particularly when it brings down the costs of doing business. But you can see how they're being used for trimming plants and crops. And in fact, these tractors here, they can drive across the land and actually identify and pinpoint every plant that's growing. So you can see here, and they can actually weed automatically. Right, so these are actively being deployed today in transforming the way that we produce food. I kind of think they're beautiful as well. And so this was like a world's first, and this is the last video of tractors you're going to have to look at, but I think it's very important to see this marriage between kind of old technology and new technology. So this is the world's first completely automated farm. And so no humans are allowed into this field. All testing is done by drones and by tractors are going in, and everything is fully automated within the field. Right, so everything from sampling to sowing to harvesting. And so these aren't ideas that are coming, 50 years, 100 years from now. This is 5, 10, 15, 20 years from now. But in fact, we need to motivate ourselves to go faster. But now when we start pushing out a little bit further, we saw how in precision agriculture we can say, hey, this is an area of the land that I like. But what happens when we start deploying en masse the ability to pinpoint individual plants in very fast methods? So there's research that's been ongoing for the last decade at Cornell University in developing cyborg insects. And the idea is, how do you hijack insects to perform under your control? And so you can see in this video, essentially they're sending a signal to this little beetle, telling it whether to go left or right. And so the beetle has a backpack, a little backpack on it. And that backpack then sends an electrical stimulation into the beetle, which then triggers its wings to go left or right and allows you to actually guide it. Again, this technology is very early stage, but this is one of the signals that's prescient of what's to come. If we want to move away from cyborg insects, there's a huge development happening in robotic bees. Right, so many of you may have watched the Black Mirror episode about robotic bees. Those are real. And in fact, those bees are being currently researched and developed at Harvard at the Wyss Institute. And the idea behind these is what happens when we lose all of our pollinators, right? So we can obviously modify our behaviors and develop technologies that prevent, global climate change and other catastrophes. But we also should acknowledge that maybe we're not going to go fast enough, and maybe climate will change. And maybe we are going to have those catastrophes. And so what if we did lose all of our pollinators and we had to replace them with robotic pollinators? So here's an example of something that is being developed in that case. And so the idea is that you would have these autonomous pollinating robots that you could throw out into a field, and they're going to bounce around the plants and perform the duties that potentially collapsed bee population used to be able to do. So when we move out of the field and we start going into closed systems, we start seeing a lot of other advantages, like complete control, right? So closed system farming suddenly says, well, let's do away with all the external environmental pieces of disease, or external disease, climate, everything we can't control, and says, hey, let's control everything. And we're starting to observe that these methods are being brought into cities, and we're getting a huge development of urban agriculture. specifically, aeroponic systems, aquaponic systems, hydroponic systems that are now starting to feed, large parts of our populations. In fact, many of the greens that you consume come from systems like this. But what I love about this is that these technologies are now being brought down to the consumer level as well. And there's a great group out of MIT that creates this thing called the food computer, as you can see here. And so the idea behind the food computer is for an individual to be able to grow food at home, but they don't have to think about how to control all of the environmental components. All they do is, and so in this case, this is a very DIY type thing. It's an open source DIY piece, so you can build it. But they don't have to think about all the different optimizations around how to grow their food. They can download a recipe on how to grow their food. And what does that mean to download a recipe? Well, that would download the temperature, the lighting, the chemical components that are needed in order to grow your food in the best way. So this is being used for consumers, but now this is also being applied in terms of high throughput testing of plant growth, right? So if we use image analysis and we start developing and refining these growth recipes, we suddenly can produce higher yield foods because we have better information on the conditions in which they grow under. And then we're starting to see how this is translating over further into the home, into fields like personalized food, right? So what does it mean to have personalized food? Well, when you walk into a grocery store today, not all food is created equally. The nutrients found in one head of lettuce might be different than the nutrients found in another head of lettuce. On top of that, you as a person might need different micronutrients than another person does. And so there are technologies such as this one, which is called Sprouts.io, that are looking to develop in-home technologies that can then produce food that's meant for you. And that's both your nutritional preferences or requirements, but also your taste preferences. And looking at how we can merge those two, right? Because if we change the growing conditions, even the slightest, for any plant, we can actually make them, if it's a greens, we can make it spicier, we can make it sweeter, we can make it crispier. So this area is very actively being worked on, but you're starting to see how, food production is not just something any longer that belongs in a field far away, but it's actually something that we are bringing closer and closer to our cities and into our homes. And now to just, scan through kind of the other things that are happening in food production, we've seen the onboarding of 3D printing in food. We haven't really seen why it makes sense. There's no kind of golden solution here, but we are observing that 3D printing could potentially be useful in the creation of cellular lab-grown meats, right? So where we might actually print out a steak rather than, harvesting it from a cow carcass. But we don't quite have a silver bullet here, but it's still in progress. But now we are seeing the advent of cellular agriculture-based products. So for those who might not be familiar, cellular agriculture is the idea of applying tissue engineering techniques and laboratory techniques in order to grow previously animal-based products. So there's a company called Perfect Day. They have an animal-free dairy line. What they're doing is essentially taking all the DNA sequences that code for all the different proteins in milk, and they're throwing those into yeast. They're growing that up in a bioreactor the way you would do many other processes in the food industry. So it's a very standard process. And then they extract those proteins, mix them together, and make milk. So this, from a nutritional perspective, is identical to the milk you would have from a cow, but doesn't have the same impact. And further, we have cellular agriculture also that's looking to produce meat. So we're taking, the last 50 years of tissue engineering work that was applied to, repairing the human body, and we're applying it now to growing steaks in a laboratory. Right? So we're saying, how do we make ground beef, make steaks. And in fact, the first lab-grown hamburgers have been created. The challenges here right now are that the costs are quite high to produce these products. But the question remains, how do we pace that technology faster and faster so that we can take away the burden that traditional animal agriculture has? As we watch that transition of proteins happening, right, a shift in where we're getting our protein from, we're starting to see new sources of protein. The World Health Organization has shared that over 2 billion people today consume insects as part of their daily diet. Right? So what would happen if we could introduce insect proteins into the rest of the world and actually start shifting further from animal products into protein sources that have less of an environmental impact, right? And crickets in particular, they're about 8 times more efficient to produce than beef on a per kilogram basis, right? And what that's saying is the resources we use to grow a cricket, whether that's food or water, are far less than the resources used to grow the equivalent in beef or other meat products. But then we also have to reevaluate what we're growing, right? So farmers are growing a lot of the crops that we've had for many years, but we have to start saying, hey, are those crops good for the ground? Are they good for the earth? How are they contributing? And there's a new cross between wheat and wild grass called kernza that has actually attracted a lot of attention. Why this is an interesting plant is that it's a perennial rather than an annual. Right, so many of you have been to a garden center, you probably know annuals, once a year, perennials are going to come back every year. Wheat is an annual, right? So we plant it every single time we want to grow it. So we go through that whole process of driving across the field and planting those seeds, and that leads to tilling and leads to all these disturbances to the soil, which then makes the soil less productive. So if we were to grow plants like kernza, suddenly we're only doing this once every 3 to 5 years. Right? So as a perennial, this plant is going to grow year over year. Some of the challenges that still exist with it, though, are that it yields far less than traditional conventional wheat, so we're getting about 1/3 of a yield. And then also the applications. This isn't the best grain for making bread, for example, but it could be used for other feed purposes. But it's also incredible to see how it grows. So in each of these images, you can see across the months, on the left-hand side is conventional wheat, or an annual wheat, and on the right-hand side is kernza. And you can see the root systems of kernza go very, very deep, right? Like, this is well over 2 meters down into the ground. Again, why is this important? Well, those root systems actually keep carbon within them. Right? So suddenly this becomes another tool for sequestering carbon within the ground and within the soil. Whereas conventional wheat, as you see on the left side, those root systems will decompose year after year. So in fact, we're not actually capturing anything. We're just going to release it on that annual basis. And there are many really cool projects happening in plant development. One of them at the Salk Institute, which is really trying to figure out how to create this ideal plant. So kernza is one of them, not from the Salk Institute, but kernza is a plant that people are exploring. But they're really saying, what are the building blocks of the ideal plant? How do we genetically create the ideal plant? And what does that ideal plant do? Well, it sequesters carbon in the ground, is basically the number one thing that it can do. But this is exactly what it looks like. So a regular plant, exactly as we looked at with kernza, the root systems decompose and then they let CO2 back into the air. Whereas when we have these ideal plants, we have these massive root systems that, using the cork or the suberin that they have in them, actually holds carbon in the soil much longer. Something we do have to acknowledge, though, as well, is, we might run into trouble. And we might not be able to grow food the way that we've traditionally grown food, and we might really have to push into producing new GMOs that are going to be far more responsive to the environment at large. And that's not necessarily a bad thing, but we do have to acknowledge that this is a technology that is useful for protecting our future food systems. CRISPR has been an incredible technology in crop science in general, because it allows us to edit genes directly within a plant and be super specific about the genes that we're editing. And so if you can think about the way that plants are traditionally bred, they're doing cross-pollinations between plants, and in fact, to bring a new plant to market, a breeder works for 7 to 17 years, right? And so if you go to Agriculture Canada today, they are creating strains or varieties of wheat right now that are going to address problems that we're predicting in 2025, 2030, right? So those are very long timelines. Whereas when you start introducing technologies like CRISPR, you have the potential to turn that into 1 year, 2 years, 3 years, right? So it drastically reduces the timelines in how we produce food that can actually respond to a changing environment. And so I'm going to slowly round out here, but really, we always have to ask ourselves, like, what can we do ourselves in the short term and in the immediate term? And I think it's really important to observe the new Canada Food Guide and how it's transitioned into, sharing with us, like, hey, we need to have protein, and we probably want to focus our proteins on plant-based sources, right? This is a huge shift in the way that we've been communicating how to eat. The thing that is missing here, though, that has already been addressed by other countries like Sweden, Brazil, the Netherlands, is the understanding of sustainability within the food guide, right? So we're not just talking about how the food we consume provides for us internally, but we also need to understand how it affects us externally in terms of impact on the world at large. And so, as a take home from this, it's really like the thing you can do today, and in fact, if I got to run a dictatorship here for like a month, I would just say, okay, like we're all shifting how we're eating today, like right now, because it's unsustainable how we're eating. But the things we can do as individuals is really start to diversify the ways we eat, right? Be more of a flexitarian, take pressures off the systems that exist, and allow ourselves to transition to better eating patterns and start evolving technologies into agriculture that then will provide for us. And so ultimately, we really do need to shift from that 1960s green revolution, that was optimized around producing a lot of food and to minimize, the number of people that didn't have food. And we need to move towards what I'm describing as a connected revolution. Really a system that is both looking at the needs, the demand, and the supply side and connecting those dots holistically. So not just through calories and nutrition, but also through sustainability standards and environmental standards. And so going back to the dinner table, again, every time you sit down at the table, look at what you're eating. Make conscious decisions about what you're consuming because you need to understand that you're negotiating with our future. Thank you.
All right, we have some time for Q&A, so please get a hand up if you have a question. A mic runner will come out to you. While you're digesting that, I actually have a couple questions for you, Irwin, that we can maybe kick off, but please jump in. We've talked twice now on the program about cellular agriculture. I mentioned it in passing yesterday in my intro session, and now you talked about it a little bit again today. Could you tell us a little bit more about how that actually works, the idea of the bioreactor, biofabrication, the hacked yeast, and then also what are the limitations in terms of what we can produce?
So there's two very different processes happening in cellular agriculture. So when I talk about dairy, this is more of in the food production business, a fermentation process, whereas in meat, we're actually looking at tissue engineering. So if we start with the meat side of things, what we're looking at is going to an animal and extracting stem cells from that animal, right? So we're saying, hey, let's get some, stem cells out of you that then I can propagate and grow and divide into the cell types that I want. So when you actually look at what a steak is, right, it's made up of different muscle cells and fat cells, right? So for the most part, that's what you're getting as a mix in there. And so we want to take those stem cells and grow them into muscle and fat cells and provide a balance to that, and then eliminate the animal from the picture. Limitations on that, and the biggest today, is that the media, the actual nutrition that we need to provide to those cells in order to grow them is in fact derived from animals. And so there's a huge shift towards synthetic media, but the synthetic, as we call defined media, is very, very expensive. And so fundamentally, both sides are very expensive, but the synthetic, the truly animal-free side is very expensive. And then going to the other kind of practice of using fermentation processes, these are, and we should be very transparent about what these are. These are recombinant organisms, meaning that they have the genetics of them changed, right? So we're taking yeast and we're putting inside those yeast genes that code for the production of milk, right? Of milk protein, so casein and other milk proteins, right? So then we grow those up, and you may have seen bacteria in a flask before, so that's really what it is, just we're doing that large scale. And then we have to take that all together, pull out those proteins and mix them. So, it's a question about what we're comfortable with. And, these are processes that already exist and that we already use, but I think the consumer needs to be aware of how they're being implemented.
When I brought up the example yesterday of Modern Meadow, which is using a similar process to produce leather, right? Is it any organic compound? What are the limitations of what we can produce with this micro factory?
It's really figuring it out.
Okay.
That's the question. So Modern Meadow, actually, they started in the meat business, but what they realized very quickly is that that path would be a very long path. And it is. There are no steaks coming for the next 20 years. It's not going to happen. Hamburgers maybe sooner. Some people say that they're coming to the market very quickly. Much sooner, in the next couple of years. But to have something structured like a steak, that's far out. So Modern Meadow made a shift, and their original thing was actually 3D printing steaks. And then they started applying that technology to creating leather. And so these are animal products that are animal-free, right? And for them, it's more about processing. So they're taking those stem cells and they're growing up skin and all the different levels that you have of skin, but then they have, and I don't know the details of their process, it seems proprietary to some extent, but obviously you have to have some kind of tanning solution and some processing is happening, some magic is happening that's turning it to leather. But incredible if they can actually do it and bring it to market at a competitive price.
Enough for me. I see hands that are not my own. Greg.
So are you a proponent of frankenfoods going in that direction, or more just making it, like you've talked about, making the existing foods more efficiently produced?
I think we have to take a multi-pronged approach here, and we have to really look at all the available options. The realities are, if I could convince every single person in Canada to completely change how they're eating, and I could get the government to regulate agriculture to have better practices tomorrow, we could stick with just making the really incredible food that we have access to today, right? Sorry?
We don't have a food problem in Canada. It's really, based on your map, it's in kind of sub-Saharan Africa and...
Sorry, so Canada is a huge exporter of food in the world. So, right, we have to separate out these different problems, right? So one of the problems is hunger, right? So Canada does have a hunger issue, and we have a major distribution issue still, where people who are, there are people who suffer hunger and are under the poverty line, but let's pull that issue out. It's more about the sustainability of the practices of agriculture in Canada today that are having a more global impact, right? We use most of our acres of land to export things like soy and wheat, and that's not right. We're not producing those things to consume them here in Canada. We're shipping them out, and so being such a fundamental core nation in the world global supply food supply chain, the decisions we make are going to impact that entire system. So I really do believe, I want us to make those transitions and stick with creating really good food that we already have. We don't need new food if we're able to make decisions quickly enough. We already have lots of good food, right? And I don't want us to be confused about that. We're really good at making food that is nutritious and is good for the world. We just don't do it. And that's it's a decision. It's 100% a decision. It's not because we can't. It's because we don't. And we won't. And I can say there's a lot of reasons for that, and the other side of it is why we do need to go into, as you described, frankenfoods, or actually explore GMOs, and why GMOs are necessary is, what if we're screwed and we're too late? The wheat that we're growing right now isn't going to grow very well in a world that has, exceeded that average temperature by an extra 2 degrees. It's not going to grow. We're not going to be able to grow the foods that we're growing today. So we need to find some shortcuts. And those shortcuts include things like using gene editing and CRISPR technologies, right? So this is why I say, we have to look at all of our available options, and we have to say, this is basically if we're responsible, what we're going to do, and this is if we continue to be irresponsible, what we're going to do. But we will find a solution.
Thank you. So I have deep background in the global supply chain of ag, so I appreciate all your comments. And I do think, and thanks for talking about precision farming, because we're well ahead of the game. And I know there are many blocks to why we don't do what we can do, and that doesn't just apply to agriculture, it applies to multiple industries. So I want to talk a little bit about that connected revolution. Can you get out of Canada and talk about the global supply chain in the terms of the connected revolution? Because there's great things happening globally that kind of go into solving this problem. Because the other part, I think, the misnomer that we get is that we're not going to have enough food to feed all these people. Yet we're still, what is it, 2 billion, like 11 billion, right? Like we can feed. So that's not really the compelling reason to move to the connected revolution. Can you talk about that from
Sure.
like a global perspective?
Yeah, so this is a complex question, but I'll break it into different parts. Number one is around, the food that we produce today, right? So we do produce an excess amount of food today. As we said, we could feed 10 billion, 11 billion people today, and we only have 8 billion. We have a major distribution problem that's happening, right? So like if we actually look at it for what it is. In the meantime, though, over the course of the next 30 years, we do already see that there's changes happening in agriculture that are reducing the yields and the amount of food that we can produce on existing land. And so it's forcing us to actually use more land, which we know will not allow for us to meet global climate change goals in the future, right? So we have to actually think about what that future state in 2050 looks like, which suggests that, in fact, we might not be able to produce enough food for those 11 billion if food production actually goes down, right? I'm saying if we're meeting global climate change goals, right, which are limiting the amount of land that's being converted, so like those are things that have been decided. So if we're working within that as the framework, you're right. Again, if we do choose to use that land, though, we are going to accelerate the progression of, the impacts of using that land, right? So like this is where it's like it goes back and forth, right? It's self-propagating in that sense. That being said, on a global perspective, I think it's really important to note that like food, and again, this is a challenging thing to put out there without kind of looking at all the context, but food doesn't 100% need to be local, right? The best place to grow wheat might not be in this room. It might not be right here, right now, right? We do have a global food system that in some ways already has found a lot of those efficiencies of where are the best places to grow food, and then how do we move that food around the world, right? And that buffers us very well against changes that happen, in terms of production, right? Like we can't predict what yields are going to be next year in Canada. When a farmer puts his seeds in the ground in the spring, he's crossing his fingers. Like he has no clue what's going to happen. And it's year after year like that. So on a global perspective, by connecting these dots further and further, we'll be able to shift production in a smarter way. If that's, without getting too deep into it, that's kind of where I see this connection happening.
You're talking a lot about changing the way that we consider the dinner table, and therefore talking about the changes of our behaviors around food. How might we design a simple visual system to educate the masses about their choosing and the selection of what they put at the table?
100%. It's funny, I was legit thinking about this last week. We just need, it can be so simple. Things don't have to be difficult. From the nutrition perspective, it's a color and a shape, and from the environmental perspective, it's a color and a shape. People are very visual. If we had clear icons, we don't muddy up the entire front of a package with every designation that doesn't really mean anything. People are inventing designations, and we just gave clear information. Let's say this is 3, carrots for being more sustainable versus 1 or versus 5. It can be very simple that people can just see and they can make the decision. And that's the biggest thing that's missing. If I had my way, I'd say the way that we've introduced calories to restaurant menus, we should introduce sustainability to those menus, right? So this is the caloric impact on you, and then this is the external impact on society because you wanted to eat this burger, which it's a choice. Thank you. We got some fans over there.
Thank you. I learned a lot from your presentation, and I was really taken with your reference to personalized produce, and then imagining that personalized food is something you think about. And can you just talk a little bit about the future of personalized food and what perhaps you and others may be thinking about if you join it up with personalized medicine and
100%.
healthcare, both prevention but also treatment?
So that's like one of my favorite things to think about. So that's actually my background was in developing platforms for personalized medicine, right? So the idea was, how do we take, what exists within a laboratory, millions of dollars worth of equipment and put it something the size of a credit card, right? It really was about point of care diagnostics, specifically in that context, but then allowed for screening, drug screening, and then that then further allows us to say, hey, how do we treat this individual patient? So the transition to food, for me, is one and the same. And it's very important for us to understand how food impacts an individual rather than how it impacts a population, right? Which is the exact same problem we have in medicine. In medicine, we're looking at studies that are, we're looking at 1,000 white men in their 20s as the marker for how a medication will affect a woman in her 50s. Like, it doesn't make sense necessarily. And so that's why there is this huge shift. And this is just for context. That's why there is this huge shift towards personalized medicine and then personalized food. As we start seeing, and so I didn't go super deep into this today, but as we start seeing everything connecting, that's an important component to all of this. You can imagine a situation, and I've given this example before, but when you walk into a juice bar, right, you're making an emotional decision on what you're purchasing, right? So there's a green one, an orange one, a purple one, a yellow one, and they have different names, so that's marketing. That's not information, that's just marketing. And you might have some preference for flavor, but the reality is you're making a huge value proposition. You're spending $15 to get 8 ounces of juice. And you're making that from an emotional basis under a lot of presumptions of how that juice is going to impact you. Right? You have no idea which vitamins you need. You have no idea if those vitamins in this juice are actually available to you. And so that's the future that I would like to resolve, is like, how do I make those choices? How do I make those decisions? Right? How do I walk into that juice bar and, let's say, have an embedded continual monitoring device that's looking at my physiology at every moment in time, and it says, hey, I understand this menu, and this is the drink that you should choose. Or it gives me the recommendation. I'm still a human being. I still have the right to choose. But when we go further into connected system, and this is where we're going to make a little bit of a leap, imagine that physiological demand is now understood from a community, and then from a city, and then from a country. And suddenly we're able to understand the foods that are needed in order to completely feed society. Right? So the demand from those continual monitoring devices suddenly is actually putting the pressure on supply, right? And obviously there's time issues here, but again, if we leap forward, we can have more predictive technologies around, hey, this is the current demand, this is what the demand will be, this is how we should use the resources of agriculture around the world in order to support that. So it's really at every single level where you'll start to see these connections happening. Right? So agriculture is one component of it.
I think we have time for one more question. There's a mic already out, I believe.
Yeah, so one of the themes I see here is there's always the concept of choice. But what happens when there is no choice about people deciding what they can and can't eat? Particularly in our communities and in our province, where the child poverty rate is 27.4%.
Where?
Highest in Manitoba, highest in Canada. In my federal riding, the Churchill riding, it's 64.2%. So when we have no choice about what we eat.
So it is a choice to have people who are hungry and malnourished, and that's not a personal choice of that individual. That is the choice of the people. There is no reason why anybody is hungry ever. There absolutely is no reason. It is regulation and policy that drives that. And These are not problems that don't have solutions. I'm from Manitoba as well. Actually, I flew in from Winnipeg yesterday. You know, it blows my mind. Like, you're surrounded by food. We're in like this is like the heart of the country's like wheat fields and soy fields. Like, all the food is grown there. How is someone going hungry? And this is a choice of policymakers. It absolutely is. And so from the individual's perspective, I agree with you. Like, there are these moments where we are confined by having limitations to what we consume. And I hate to say it, but that's out of our hands. You know, that's something that needs to be, like everybody in this room needs to demand that that's unacceptable. Like, at the end of the day, that's what it is. It's like you need to be vocal and you need to say, it is so crazy to me that there is a child anywhere in Canada, never mind in the world, who's hungry right now, when we grow all this fucking food, excuse me. It makes me like really angry. Like, it's mind-boggling. And then in Canada particularly, we're wasting 56% of our food. Like, yeah, I don't have an answer to that. I'm sorry, but it's a very legitimate challenge.